So we're going to watch a short video that's going to talk about the independent and dependent events that we took notes on yesterday in class.
Jason is tossing a fair coin, and he tosses the coin 10 times, and it lands on heads 8 times. If Jason tosses the coin then an 11th time, what is the probability it will land on heads? In this lesson, you will learn how to analyze independent and dependent events by finding their probabilities. Let's review. Theoretical probability is what should happen in a situation, according to our mathematical reasoning. And we can represent that as a ratio as the number of ways an event can occur over the total possible outcomes. So if we're taking a look at an example using a bag of marbles that has 4 blue, 3 red, and 2 green marbles, and we're trying to find the probability of picking a red marble. So let's organize our marbles here. The total ways or possible outcomes are 9, because there's 9 marbles in the bag, so that's a denominator. And the number of ways that we can pick a red marble is 3, because there's 3 red marbles. So our probability of picking red would be 3/9, which actually reduces to 1/3. Now, in the common mistake, we're going to take a look at the same example with the bag of marbles. Another question might ask you, what is the probability that the second marble will be red? And a lot of students will say, well, it's the same bag of marbles, so the probability of red is 1/3. But that's actually incorrect because our situation has now changed. If we look at our bag of marbles and we pretend that the first marble picked was red, then now the number of possible outcomes has completely changed, and we need to analyze this again. So now there's only 8 possible outcomes, so when we're trying to find the probability of red in the second turn, then there's only 8 in our denominator. Those are the 8 possible outcomes. And now only 2 marbles are red. So our fraction is 2/8, which reduces to 1/4. That's how our probability has changed after we're picking a second marble. Let's take a look back at that opening question, in which it told us that Jason tosses a coin 10 times and got 8 heads. The question was asking what's the probability that the next toss will be heads. It's important to understand here that we're not trying to find the experimental probability, because then we would use Jason's past results. We're only trying to find the theoretical probability. And tossing a coin is an independent event. There's still only 2 options, and one of them results in heads, so our probability is still 1/2. Tossing a coin is an example of an independent event, and those are ones that are not affected by previous events or events that follow. So it didn't matter what Jason got previously, the probability of getting a heads is still 1/2. So then, dependent events are then those events that are affected by previous events or events that follow. So, for example, the probability of a child being born with green eyes depends on the genetics of the parents. The probability of a child having green eyes depends on the heredity of his or her parents. Let's take a look at another example involving marbles in a bag. This bag has 2 blue marbles, 3 green, and 3 red. The question is asking us, what is the probability that the second marble will be green? And this would be an example of another dependent event, because unless this problem specifically tells us that the marble was put back, then we need to know what the first marble picked was. It's dependent on the first event. So let's pretend that that first marble picked was blue, so we'll X that option out. And we're trying to find the probability of getting a green marble. So now, instead of having 8 possible choices like before, there's only 7, so our denominator is 7, and the number of ways that we can get green are 3 possible outcomes, so our numerator is then 3. So the probability of getting a green marble is 3 out of 7. In this lesson, you have learned how to analyze independent and dependent events by finding their probabilities.